I'm explaining. All right, 6th grade, I'm glad you guys all had a good weekend. Hopefully you're a little more awake tomorrow. Our lesson for today is to learn about a matrix, and this has nothing to do with the movie The Matrix. This is learning about a math matrix. So you're probably wondering, well, why is this in the Chapter 1 packet? We already took our Chapter 1 test. This is more of a bridge from Chapter 1 to Chapter 2. Does anyone know in math what you use a matrix for? Anyone know what we use a matrix for in math? Doug, do you know what they're used for? Okay, yes, arranging a set of numbers. Anyone know what else we use a matrix for in math? To be honest, do you know? Okay. You're smiling. You sure you don't know, or does the word just sound funny to you? Or you're just laughing? You're just laughing. Mary? Yeah, that's another option, multiplying. No one else has heard of a matrix in math, like what they're used for? Charles? Good. Adding, subtracting, multiplying, dividing sets of numbers. Yes. Okay. All right. So let's go over the warm-up, and then I need to tell you more specifically what they're used for. So the warm-up was just supposed to be a review of adding, subtracting, and multiplying integers and going over the rules of positives and negatives. You all proved to me on the Chapter 1 test that you have mastered that skill and you know how to do that. So number 1, I know there's decimals. Charles had asked, how do you multiply decimals? We will get to that in Chapter 5. Okay, good. The point of this for now is just to go over the rules, even though they did throw decimals in here. So Doug, what did you get for number 1? Okay, Alyssa? Good. Alyssa, why is it negative? Good job. The larger number is negative, so your answer is negative. Very good job. Mary, number 2. Good. Why is it positive? Good job. 2 negatives back to back makes a positive, so that larger number is actually positive. Charles, number 3. Why is it positive, Charles? Good job. It's positive because there's 2 negatives. Charles, do you have a question or? Okay. I thought you had a question. Okay, let me get someone else just because you already answered. Sorry. Sean, number 4. Good job. Negative 79.2. Sean, why is that one negative? Good. There's only one negative. If you're multiplying or dividing and there's an odd number of negative signs, the answer is negative. If there's an even number of negative signs, the answer is positive. Annalise. Okay, did you multiply from left to right? Okay, you just multiplied wrong. And remember what I said before, because I didn't teach you how to multiply with decimals yet, you may use a calculator on that. In Chapter 5, we're going to spend a lot of time multiplying and dividing things by hand. Charles? Okay, same thing as Annalise. I'm going to tell you, use your calculator to double check your multiplication from left to right. It doesn't matter, no. Okay, what I want you to do is use your calculator to double check that for now. And then in a couple chapters, we're going to be doing all that by hand. I'll give you some. I know you guys have learned. I know you have. Charles, you can open up the no slacking cabinet and take yours out if you want. Okay, if you want. Donatus? No, it's multiplication. Anytime parentheses are next to each other, multiplication. Emma? Okay, when you're adding and there's opposite signs, you need to subtract and then take the sign of the larger number. Okay? Annalise? Move the decimal point over 2 places. Okay, hold that thought because we're going to get to that in Chapter 5. I want you to get a calculator, Annalise, and check for now because we're not worried about that right now. All I wanted to go over was the rules with your negatives and positives. Okay, so if you want to open up that cabinet, you can double check. Okay, so, and I promise, we're getting to that. I just don't want to spend a lot of time on that right now because that's not today's lesson. So, key terms. So, what is a matrix in general? You can just take one out, Annalise. You can take any of them. A rectangular arrangement of numbers in rows and columns. So what is a matrix? a rectangular arrangement of numbers in rows and columns. So again, our matrix is a rectangular arrangement of numbers in rows and columns. Okay, so I made the M kind of like long because the letter M in a matrix always represents a row. I made the N nice and tall and skinny because the N is always the column. A matrix dimensions, and I'm going to show you why, are always M by N, which means it's always rows by columns. So again, a matrix is always M by N. The variable M always represents the rows. The variable N always represents the columns in a matrix. So you're probably thinking, well, what does this all mean? So let me, before I answer you guys your questions, let me keep going here for a couple minutes because I might have your question answered. So dimensions of a matrix. Well, what is this? The dimensions of a matrix are written as M by N. M is always the rows, N is always the columns. So think of N as being tall, skinny, pretty high. Think as M as written pretty wide and straight across. Dimensions of a matrix are always written as M by N. After I give you these definitions, I'm going to explain more specifically what you actually use them for. Okay, an element is each number in a matrix. An element is each number in a matrix. So each number or each term is called an element. John? I'll go right back to it. You still need that? Yeah. Did you get it? Here's okay, Jeremy, are you good or no? You need to do that one. Each number in a matrix. Doug? Okay. Well, you'll remember it after today. Okay. Scalar multiplication. So what is this? Why are we talking about multiplication with a matrix? Scalar multiplication is when each element, which means each number in a matrix, is multiplied by a real number called a scalar. So each element in a matrix is multiplied by a real number called a scalar. Jeremy, you need to keep your hood down. Okay. Okay, here's what it looks like. So for the next definition, which is a scalar, all I want you to do is draw an example. Put a 2, and then this is actually a matrix. This is the first matrix you've seen. Make brackets. Put the numbers in them. So 1, 2, 5, negative 3, 4, 1. What I highlighted is what I want you to circle. That is the scalar. That's a number that is in front of a matrix, which is kind of like the distributive property. You're just multiplying that through. Yeah. Put that on your seat. Actually, you could at least catch part of the notes with this. So a scalar is a number in front of a matrix. You might want to draw that and then circle it if you haven't already. Okay, at the bottom of your notes, this is already there. So here's what I want you to do to the matrix that's already there. I want you to make a little squiggle line, or whatever we call that, and put 3 columns. So here's a column, here's a column, here's a column. So column, column, column. Remember, N is long, tall, and skinny. 3 columns. There are 2 rows. M is always denoted as the rows. There's a row here, there's a row here. It's extremely important that you remember the dimensions of a matrix are always written as rows by columns. Rows by columns, always. M by N, always. Okay, so before we do some examples, I'm going to show you what a matrix is used for. And then I'm going to show you how to actually add, subtract, and multiply them. Not divide yet. You can divide matrices, but we're just not going to do it in this chapter. So remember, dimensions are M by N, columns go this way, rows go this way. Annalise. Yeah. I always do. I'm pretty good with that. Okay. Oh, hold on, don't write that yet. Okay, so what is a matrix? What is this actually used for? This is not in your notes. I just want you to look at the smartboard. What is this actually used for before I show you how to add, subtract, and multiply them? So later on in this book, as well as in Algebra 1, you are going to be given problems where you have 2 different equations. You need to find x and y. So if your equations look like this, can you in your head mentally figure out what x and y are? Charles? Okay, they could be, and they might be. But is it always going to be that easy? No, it's not always going to be that easy. They're not both 1, though, because -1 minus 3 is not 1. Do you know what I mean? It has to work in both equations. Right, but it has to work in both of them. Doug? You're thinking of solving an equation, just one equation. This is a system of equations. So if you're trying to find, and I know Charles, he tried, if you're trying to find the x and the y value of both equations, it has to work in both. It has to be an answer, same answer for x, same answer for y. So you can do this by hand, which if we have time this year, I'm going to teach you. If not, the reason you use a matrix is to solve for the x, the y, and if there's a z, you could even solve for x, y, and z. What you do is you take the coefficients out of the equation, you put them into a matrix. Now you can also do this by hand or in the calculator. There's a button in the calculator called RREF, which reduces your matrix down to, this is called row reduced echelon form. There's going to be a number here, there's going to be a number here. So what this does is, this is called the identity matrix because it really means 1x plus 0y equals a number. What does that mean? 1x plus 0y equals a number. Charles, what does that mean? Good job. This first row, the number is x. The second row is 0x plus 1y equals a number. What did that one solve for? What variable? Mary? Good, that's all for y. So this number is always x. This number is always y. Last year when I had the 7th graders, I taught them how to do this by hand, but you can also do this on your calculator. So I know that's a lot. Basically, all I want you to know is that a matrix will solve for 2 or 3 variables in a system of equations. If you have 3 equations and there's an x, y, and a z, a matrix will allow us to find all 3 of those variables that makes both equations true. It has to be a true solution. Mary? could. Sean? Go ahead. Yep, you're right. That can work. That can work. He's right. Yeah, 2 times 2 is 4, minus 1 is 3. He said 2 and negative 1. So that definitely can work. And sometimes there could be more than one answer, but we'll get into that later. Good job. Annalise? Okay. Whenever you have a matrix and you put the equation into you put the equation in there. This is always x, this is always y, this is always what it's equal to. So if you have 1x plus 0y, the y goes away, and you're left with x equals a number. If you have 0x plus 1y equals a number, the x goes away, you're left with 1y equals a number. I was doing it for the problem above. If I were to teach you guys how to do this by hand, this is what you would end up with. If we were to put this in the calculator, this is what we would end up with. Annalise, I skipped a bunch of steps in here. I'm just showing you guys why and when you would need a matrix. I'm not showing you how to do this. Did you remember what I said? If I had you in 7th grade, we will. Today, no, I'm just giving you the basic overview of what a matrix is. But if I teach you something you haven't learned yet, I like to tell you when you would use them and why you might need them. So I didn't show you how to do this. It's just an overview. Okay? All right. So let's go back. On the next page of your notes where it says examples, it says matrix addition and subtraction. I want you to write next to that must have the same dimensions. So where it says matrix addition and subtraction, I need you to write must have the same dimensions. Very, very important that you remember you cannot add or subtract a matrix unless they have the same dimensions. Rows by columns, rows by columns. Okay, so let's do an example. Letter A. What are the dimensions in letter A? What are the dimensions, Emma M? Good. Charles, what are the dimensions of the second one? Great job. Rows by columns, rows by columns. 2 rows, 3 columns. 1, 2, 3. Why are you with us? Okay. So we're adding them. Anyone have any idea how do you add the elements in a matrix if they have the same dimensions? Doug, what do you think? Oh, I'm sorry, you went down. Yes, you're exactly right. So here's what you do. Throw this down. Okay, 0 plus 2 is 2. 4 plus 1 is 5. Negative 1 plus 3 is 2. Negative 3 plus negative 2 is negative 5. 2 plus negative 6 is negative 4. 5 plus 4 is 9. Very easy. Now, why would this part of matrices be in chapter 1? Why is this part of matrices in chapter 1, Briar? Good. Adding, right, in this particular example, we're adding and subtracting integers. Now, yes, there's a much more advanced level and reason that you're learning matrices, but this is basically just a review of, all right, well, how do we add integers? How do we subtract them? Emma? I added this to your book because I like you guys to see it. The way it's planned now, no, but if we have time, yes. Because I like to show you guys things you'll see later on. Okay? Let's go to letter B. Okay, letter B is a subtraction problem. So be careful on this one. Let's go over the dimensions first. Mary, what are the dimensions to the first matrix? Good. Rows by columns. Adam, what are the dimensions in the second one? Good. You have to have the same dimensions to add or subtract. Rows by columns, rows by columns. Okay, Emma M, do you have a question or? Good. Oh, yes. You could have a matrix this big. I mean, we could have I mean, I could keep going, and then you could have a ton of numbers. Yes. Now that would be a little crazy. That's actually a good bonus question on your next quiz. Jeremy. Subtraction. That's okay. No. That's, hey, no, ask any question you need to. Of course, that's related to what we're doing. That's related. You're good. All right, Alyssa, what's negative 10 minus 9? Negative 10 minus 9. Good. Negative 19. Doug, what's 2 minus negative 2? You guys are rusty. 2 minus negative 2. Okay. All right, let's try this again. Okay, Justin, what's negative 4 minus 4? No. I'm just messing with you guys. Negative 4 minus 4. Not 0, but negative 8. Good. It's Monday. That's my excuse for you guys. Matt, what's 7 minus 8? Good job. All right. What is, Donatus, head up, please. What's 7 minus negative 5? Yeah, I'm asking you. What did you say? Yep. Okay. Nope. 7 minus negative 5. 2 negatives back to back become a plus. Okay, Charles, what's negative 13 minus negative 11? Good job. All right, so besides being rusty on subtracting, answers yours. Take each element, subtract them, put them into the matrix. Dimensions have to be the same when you're adding and subtracting a matrix. Okay, I want you guys to try C and D. So try C and D. When you're done, put your pencil down, please. C and D. Just C and D, and then put your pencil down when you're done. While we're waiting for everyone, what do you guys think of these? Yeah, pretty easy, but did you guys understand what I said about the higher application of when we use these? That's the part that I thought was kind of cool. They are pretty easy, but it's nice to see them now that when we get to the harder part, you know how to use them. M? Okay, wait. That's why I told you guys to wait on that. Good job. Okay, let's see. Who wants to tell us the answer for letter C? Sean. Close. Good job, positive 13. 8 is correct. This 8, 4 minus negative 4. That's all right. They get tricky. Annalise? Well, okay. So this one should be negative 2 minus 3. Negative 2 minus 3 is how you get negative 5. Okay, yeah, just watch your sign. It's subtraction, just like Jeremy said. How do you know if it's subtraction or addition? Look at the sign in between the matrices. Jeremy's laughing, I know. It is so small, but that was a good question. If it's a plus, you add. All right, Justin, what did you get for letter D? Okay. Good, lots of 3s in this one. Not sure why I made that one like that. All right, good. Mary? You okay? You sure? Okay. Any other questions on C or D? Okay, letter E. I didn't have you guys do that one. So my first question to you is, what are the dimensions of the first one? What's the dimensions, Matt? Good, 1 by 3. What are the dimensions of the second one? Zach? Good, 3 by 1. Are the dimensions of the matrix the same? No. Can you subtract them? No. Cannot do, the dimensions are different. Charles? There's not. When we multiply matrices, you can multiply them like that, but you cannot subtract. Nope. No. You cannot. That would be pretty cool, but I promise you, I took a class at Penn State called linear algebra, and it was an entire class on matrices. Very cool class. Cannot do this. For a semester. No, for a semester. For a semester. For what was it, like 15, 16 weeks. No. No, sorry, not a year. When I was at Penn State, for one semester, we spent a lot of time on a class like this, which you see much more application of them. So Charles, I promise you, you cannot do that. Mary? I'm sure she did. If you do any kind of math, science, medical major, you typically take a class called linear algebra. Okay, yeah, I'm sure she saw that. Annalise, question on that? Nope. They have to have the same dimensions for addition and subtraction. Okay, so let's go over the scalar multiplication one. On letter F, what is the scalar? On letter F, what is the scalar? Doug? Good. The scalar is 4. So all we're doing here is multiplying. When you have a scalar in front of a matrix, it's like the distributive property. You're taking this 4, we are multiplying it through. So, Alyssa, what's 4 times negative 8? Negative 32. Donatus, what's 4 times 0.5? Good. Jeremy, what's 4 times 1/4? Good. Alex, what's 4 times negative 1/8? Good job. Positive or negative? Good job. Great job. Negative half or negative 0.5, either way. Annalise? We did, when we did keep, change, flip, do you want to remind you how to do that? 4 times negative 1/8, you multiply across the top, across the bottom. So it's really 4 over 1 times, and then multiply across the top, across the bottom, and then simplify. Okay, let's skip letter G. Let's go to the closing, which is try this one. All right, so this is where they get to be a little bit more fun. Yeah. Try this one. All right, so where do we start? Where do we start on this? What do you guys think? Doug, what do you think? Good job. So we're going to rewrite the first matrix. So negative 6, negative 8, 8, 14. In the second matrix, Doug said multiply the negative 7 through. I completely agree with him. If we multiply the negative 7 through, what operation goes in between them? Charles? Awesome job. Extremely important that you remember, if you're multiplying a negative through, then we're really adding them because we're adding the opposite. We're distributing a negative through, so then we're going to end up adding these two matrices together. Mary? Okay, I'm going to explain it again. So we're going to distribute a negative 7 through. When you're multiplying the negative through, you're taking the negative with it, okay? But just because you're taking this away, Mary, and anyone else that needs this, that doesn't mean that you're multiplying the matrices together. That means we're adding them. Now, if that confuses you, you can take a positive 7, distribute that to everything, and then you could subtract the matrices together. So if you would prefer to take a positive 7, multiply that through, and then subtract the matrices, you get the same answer. I don't like to do that because sometimes you guys forget about the negatives. So that's why I like to have you multiply everything by negative 7 and then add the matrices together. Remember, adding the opposite is the same thing as subtracting. Does that help a little bit? Okay, Annalise? Yep, yep. Okay, that's what I just explained. Can we explain it again? Okay, give me a second here. Doug? Not right now, we're almost done. Okay, so let's multiply first, then I'll explain that one more time. Charles, what's negative 7 times 5? Good. What's negative 7 times 13? Anyone can tell me this. Emma M? Good, negative 91. What's negative 7 times negative 10? Emma H? Good. What's negative 7 times negative 11? Matt? Good, 77. So let me explain that one more time. We are multiplying a negative through. If you multiply a negative through, okay, we are taking that minus sign with it. So when you're subtracting, subtraction is the same thing as adding the opposite. So we distributed the negative through. You're not subtracting anymore because you took the negative with everything. You changed this to addition because addition is the same thing as subtraction. We were adding the opposite before it was subtracting. Annalise, does that help a little bit? Okay, then don't do it the other way then. That doesn't make sense. Okay, just all you need to remember is subtraction is the same thing as adding the opposite. If you remember that, that's all we did. We made all these the opposite and we multiplied by 7. Yeah. Yep. Emma M? Go ahead. Yes. No, doesn't matter. Yeah, and I'll show you guys that at some point, but you can definitely divide them. Yes. Annalise? Yes. Okay, so let's finish this off. So what is negative 6 plus negative 35? Adam? Good. What's negative 8 plus negative 91? Charles? Good. What's 8 plus 70? This one's real tough. 8 plus 70? I'm kidding. Mary? Good. 78. What's 14 plus 77? Justin? Good. 91. So there's our final answer. You need to basically follow an order of operations to get that. Rewrite the first one, distribute the negative 7 or positive 7 through, whatever makes more sense to you, and then add them. Mary? On this one, depends on what the problem is, but the problems that we're doing today, I'm just showing you how to perform matrix operation, addition, subtraction, multiplication. The real application, Mary, is whenever you see them with equations and you're actually solving for something. To solve for an equation, Mary, you have to know how to do all this because all of this allows you to get to the identity matrix, which is the answer. So it's kind of hard for me to explain all that without showing you it. But basically, your goal will be in a couple years to add, subtract, multiply matrices by hand to get them to look like this. Does that make sense? Okay. Charles? Yeah, and I so wish I could teach you that to you guys. When we get to the chapter in your book that has systems of equations, remind me about matrices and I'll make a note too, and I'll show you that. Because yes, you can, Charles, but it's hard for me to show you that right now without giving you an application problem. Yes, yes, yes. It's pretty cool. Exactly. They're great and they're very helpful when you get to systems of equations. Doug? Yeah, quickly. Go ahead. Go ahead. Adam? I'll get to that too. Jeremy? Not this year. That's next year. But I'll show you. Mary? Yeah, thank you. I was getting to that. Okay. Matrix worksheet is in your homework packet. It is page 17. And I actually want you to do all of them. So 1 to 14. And I will tell you too, number 14, you're going to have to think a little bit. Okay? So make sure you think about it. You can all do number 14, but I want you to think about it. One other thing in your packet, there is a dot worksheet that I want you to try. Adam, do you remember what page that was on? Oh, it's the very last page, right? The very last page of your homework packet. Okay. Almost the last page. It's next to page 26. You guys see this? If you know how to do it, don't tell anyone. See if you can do this, just for fun.
That's the page I should study.
No, you can do it. You can do it. Okay? Listen, it's on the back of page 25. Okay? So try this if you have time. It's in your homework packet. You find it, Alex? Do you know where it is? It's on the back of page 25. So you have 2 assignments. Tomorrow, I will pass back your test. We will clean out binders. I will give you guys a matrix warm-up just to make sure we're all okay. Try